We have here a diagram of the respiratory system of the human. The respiratory system can be broken down into three main components, namely the airways, the lungs, blood vessels, and muscles and bones. Of course, as you know, these two big organs are the two parts of the lungs. This is the trachea. This is the lymph nodes that surrounds the trachea. You have here the right lung and you have here the left lung. Of course, we are seeing the picture in an opposite way because the person is of يعني قدامنا فحنشوف الرئة مالت اليمنى يسرى بالعكس والشخص يضرب بصوتنا يعني حيكون نفس الاتجاه. So we have the right lung. This part to here is the upper lobe and middle lobe lower lobe. مرة ما تخلص الثلاث أجزاء الأبر والميدل واللور حتجينا الريبس هذه هنا اللي هي القفص يعني العظام مع القفص الصدري that protects the lungs. On the left side is also upper right lobe, middle lobe, upper left lobe, middle lobe, and lower lobe. We have here the diaphragm اللي هو الحجاب الحاجز. We're going to take a part of each lung and dissect it more. We're going to start from inside out. We have here the visceral pleura and the pleura space and the partial pleura. Here the three layers that comes before the muscle that's attached to the first rib of the rib cage. We're going to take a cross section of the bronchioles that's inside the lungs. The bronchioles contain an artery, veins, blood vessels, air sacs, that we also call alveoli, and capillary. Air sacs is where the gas exchange occurs. Boyle's gas law, we can apply it to the same mechanism of the human breathing. Boyle's gas law equals pressure 1 by volume 1 equals to pressure 2 by volume 2. Question number 5, explain the application of Boyle's law to breathing. These are the lungs, okay? When we inhale, we take a breath in, the size of the lung will increase, okay? من يزيد حجم كل رئة you have the diaphragm اللي هو الحجاب الحاجز راح ينزل، okay؟ من يزيد حجم الرئة الضغط داخل الرئة راح يقل لأنه حجمها يزيد فحيكون سبيس أكثر للغاز الداخلي. وعملية الإكسهيل اللي هو الزفير حتكون بالعكس، حجم اللنج راح يقل، الدايفرام راح يصعد، the pressure inside the lungs will okay. هاي relationship between the pressure داخل اللنج حتكون عكسية ويا البريشر خارج الجسم. Dalton's law of partial pressure. The total pressure in a mixture of gases is equal to the sum of the partial pressure of each component gas. معناها إنه مجموع الضغط بخليط من الغازات حيساوي مجموع الضغط الجزئي لكل غاز بوحدة. So partial pressure equals total pressure multiplied by the volume fraction. Question 6. If atmospheric pressure equals to 101, 325 Pascal, then what is the partial pressure of oxygen and the volume fraction of the oxygen is 21%. They want the result of the partial pressure. So we say this number multiplied by this number, and we'll have the result of the partial pressure. Fick's first law of diffusion. The rate of diffusion is proportional to the concentration gradient. So J equals minus D multiplied by dC over dx. الجي هنا عندنا الفلكس هاي كلها اليونت مالته. D equals diffusion coefficient, this is its unit. dC over dx is the concentration gradient. Of course, diffusion is the movement of particles from high pressure areas to low pressure areas. The amount of gas, Henry's law, the amount of gas that dissolves in a liquid is directly proportional to the partial pressure of that gas. The graph below shows the solubility of oxygen in water. Use this graph to explain why lungs can't work underwater. Oxygen occupies 20.98% air by volume and 23.1% by mass. According to Henry's law, كل ما يزيد كم الغاز على سطح سائل كمية الغاز المذاب هذا السائل راح يزيد. So when, let's say, a person is drowning and their water will enter his lungs, the amount of gas in the water that entered the lung, that's going to be dissolved in the lung, will equal to the amount of gas the person is trying to breathe. Okay, so in that case, لهذا يصير حالة الاختناق in case of drowning. We have here biologically relevant diffusion coefficient at temperature of 20 centigrade. You have oxygen in 3 states, in air and water and in tissues. You have diffusion of water in water, sucrose in water, hemoglobin in water, and tobacco mosaic in water. Diffusion across membranes. Assuming a linear gradient, X, this part, is a membrane thickness. Okay, so the particles will move from C1 that has a higher pressure to C2 that has a lower pressure. The delta C between them is C2 minus C1, and the distance between the thick membrane is X2 minus X1. So dC or delta C equals to C2 minus C1 over X2 minus X1. Example, ion movements across the mitochondrial membrane. The chemical gradient of the hydrogen ion equals to 3.62 by 10 to the inverse force of 7. and القيمة مال درجة الأيون الهيدروجين الثاني هي 2.512 by 10 أس ناقص 8. الممبرين thickness مالتنا is 5 في 10 أس سالب 9. والديفيوجن coefficient اللي هو هذا the D in the equation is 9.310 multiplied by 10 to the inverse force of 9. It's very important that we convert mole to mole per liter to mole per milliliter على مود الوحدات تتطابق. We directly apply the values of each ion to the same equation, that is C2 minus C1 and X2 minus X1. هنا إنه نعطينا إياه القيمة مالتها directly without us calculating C2 minus C1 يعني نعطينا الدلتا directly. And we have here a direct application of the law. Ions are also subjected to electrical gradients. Biological application of thermodynamics to we have calories. You have this device is called the palm calorimeter. Okay,